And my name is William, some people call me the Math Hatter, and today is our first technically real lesson in math. We're going to discuss algebra. A brief history on the etymology of algebra comes from the Arabic word al-jabr, and specifically the title of the book, Ilm al-Jabr wa Mukbala by Muhammad ibn Musa al-Khwarizmi. I cannot understate how important this book was to basically the entire rest of mathematics. At the time, I believe it was written in the 9th century, so like around 800s. And al-jabr means the restoring of broken parts, which also means that in modern Arabic, if you say al-jabr, they more likely think that you mean bone setting instead of math, which is quite the difference. Al-Khwarizmi was also anglicized into the word algorithm, which is a thing that you use to actually solve algebraic puzzles. So, it's not the original intention of the word, but we made it so. So algebra, you already know numbers like whole numbers, fractions, negative numbers, which can be interesting to think about sometimes. But algebra tackles with the numbers that you don't know. Like, you have some amount of, say, some amount of beads. And you know that if you double the amount of beads that you have, you add 6 to x plus 6. We're using x because it's an unknown. If you double the amount of beads and you add 6, you would have the same amount of beads as 5 beads, 5 times the amount of beads, minus 3. So 5 times minus 3. Now, the equals means that these two quantities are the same, and we can start the process of solving the equation. Now, what I like to do first is make sure that all the numbers are on one side, so at the other side we just have x's. And to solve algebraic equations, you do the same thing to both sides. It's like if you had the 2 piles, and this one was the 2 piles plus 6, and this was the 5 piles minus 3, then we add 3 more to both sides. And now we have 2 piles plus 9, and we also have 5 piles. Now we can take away 2 piles from both sides because, again, we know that they are the same. And on this side, we have 9 beads. On this side, we have 3 piles of beads. And again, we know that these are the same. So we can just group we're going to group the beads into 3 on the side. And that's the same as dividing by 3. So the number of beads per pile is now 3. And that's exactly the answer. Because we can also, to double check our solution, substitute it back in. So here we go. 2 times 3 plus 6. 2 times 3 is 6. 6 plus 6 is 12. 5 times 3 minus 3. 5 times 3 is 15. Minus 3 is 12. And 12 does in fact equal 12. There you go. So that's the general way to solve. That is the algorithm for solving this specific kind of equation, where you just have one thing you don't know, and it's equal to some other quantity. Now, this other part doesn't have to be like another thing involving x. It could just be like another number. But that's the general thing that you want to do. You want to get it so that there's only x on one side, which usually involves adding or subtracting. Then you want to get it so that there's only numbers on the other side, which involves, again, adding or subtracting. And then you divide through and you get your answer. It's really not terribly complicated. It can get hard to conceptualize if you get things like negative numbers. Let's see if I can come up with one right here. Okay, so I have a different equation here, and now it's going to involve negative numbers as the result. So we have 2x and 15 on one side and just 1 on the other. Now we just want x on one side, so we're going to subtract 15 from both sides. Like that. And now we have 2x equals negative 14. This can get tricky, but in this particular example, you basically, when you're dividing a negative number by a positive number, first you just drop down the negative, and then you treat this number like it is positive, and then you do the division there. So 14 divided by 2, we know our 2 times tables, so that is 7. And then we just bring the negative sign down with us. That's one way to conceptualize it, like make sure that you know what you're doing. Basically, just try and fiddle around, so you're going, try the opposite tactic. You're going to start with some number. Say, you start with x equals 5. Now, what do we want to do with this? Let's triple both sides. Okay, 3x equals 15. So we multiply by 3 and get 3x equals 15. Now let's take away 7. Okay, so 3x minus 7 is 8. That's looking like a pretty good equation. Now, we could start with this and then try to work our way backwards. Or we could say, well, I know 8. 8 is x plus 3 because x is 5, so I can just put it down here. And it's as simple as that. I think that you really need to start backwards like this. This kind of backwards and forwards motion throughout it really helps you solidify the process in your brain, the algorithm. Again, I'm so sorry to this guy. His book is actually great. It's obviously in the public domain, so you can probably find it at some point. I don't know if it actually survived, but if it did, it would be a great resource to check out, because back then they didn't really have all the what most people might call the scary parts of mathematics. Calculus, which is it's going to be a couple lessons before we get to calculus, but the concepts of calculus were not invented or really thought up of until Isaac Newton was really bored in quarantine in 1666, I believe. So 100 years before America became a country, although 40 some odd years after we had already landed in Plymouth. So yeah, this kind of stuff is, I think, a really good introduction into x, especially. We call those variables because sometimes they can vary. Sometimes we just don't know what they mean. It's a really good introduction to variables. It's a good way of conceptualizing, okay, things aren't as rigid as I thought they are. It's a good level of abstraction, like I talked in the introductory episode. It just gets your mind into a different place, a different way of thinking about it, and I really think that just fiddling around with this kind of thing back and forth, making sure that you really understand it, It's going to be really helpful later in more difficult parts of algebra. Still not terrible parts of algebra, just difficult for now. But believe me, you're all smart enough. You can figure this out. Just try and come up with some of these equations back and forth. Maybe write some in the comments below. And just make sure that you really got it nailed down. Because honestly, these kinds of things, well, for me at least, I'm weird for liking math, but for me at least, this kind of back and forth way of thinking is really how I solidify a concept in my head. So just try it out, see how you do, and I do believe that you will do well. And yeah, I will see you in the next episode. Bye.